Hello and welcome to another evening of Rust. Sorry I had the wrong graphic up there, but we are doing Rust today, and we're going to do a lot of refactoring. We have a speed problem. Our little bot is going too slow. And if you've never seen the show before, we're playing on the site called Codingame, and we're competing in right now the Hypersonic, which is a Bomberman style game. We're in the Gold League. We're kind of in the middle of the Gold League, and to get further, we're going to have to actually do more searching. We're using a searching algorithm for the turn iteration, and we're using it to find the best move, and we need to look deeper. Right now, we're using way too much time up in the searching, and so we have to speed that up and go a lot faster. Quite often, I start with Clash of Code, and okay, I'm going to do it once more today. Once more Clash of Code. I'm thinking of stopping the Clash of Code, though. I don't like it that much. But let's try it again anyways. As long as I don't have high expectations, it's okay. And it's a good way to start the show, because I'm never in the Rust mood when I start. So I do sometimes do poorly on these because I'm not in the Rust mindset, but at least gets me there. And then we'll go on to the actual refactoring then after that. I like people drop out all the time. Let me know if it's too noisy with the window open. It's getting kind of hot here, so I have to keep the window open. Don't want my computer to overheat on me. It does that sometimes as the weather gets warm, and I have to clean the fan again. Haven't done that in a while. It's always good. We're going to be using probably Valgrind again today, because last time we had some suspicions about where our speed was coming from and suspicions on how to fix it. And of course, with all profiling, they weren't necessarily correct. We either have too many low-hanging fruits or none of them. So we're going to just look at it slowly and see how to do it. And we have to write a new main driver program first, because the benchmarking system in Rust is good for comparing stuff, but it's not good for actually profiling. So we're going to have to see what we do. We just have to do it as fast as possible. The square of the numbers given as input, an integer given amount of numbers to use, a line containing n space separated integers xi, the sum of the squares of the xi integers. Is that really all it is? And is this really just let mort-q equal 0.0, or 0, probably just that, q equals xi times xi? Is this really all it is? And I think so, because the other guy's already done. Play them all. We good? Let's just submit it. We'll take our chances. Alright, so that one was super simple. And something. Alright, these are really tough when they're that fast, because, I mean, you have to read fast, and I'm reading for the show, but that's no excuse. I'm just slow. Alright, so we're going to be 5th place here. No surprise. I don't think it's the amount of typing here. Some guys just understood it faster than I did. I mean, they would have had the same setup. They just had to see this exact same code. We used a Q instead of a K. Some people just prefer K. I prefer a Q. And it's a little bit quicker here. I mean, you can print stuff a little bit faster in Python. And it may not make a huge difference, but again, that could make a 5-6 second difference, and that's enough to change my position, like 5-6 seconds here or there. So, I mean, the spread here was only not even 20 seconds. That was just 19 seconds between those two. 19 seconds between first and me. So that's okay. We're just going to live with that. How was this one? This one was fun. It was fine. Difficulty, this was too easy, though. I mean, it was too easy. It's just too hard to catch up. And the statement was, it was clear enough. It wasn't that great of a statement. They might as well just I'd actually prefer in a lot of these ones, just give me the math formula. I can read it a lot faster. Alright, let's just go on to competition then. Let's go over to Hypersonic. Let's join this, and we're going to set up our external coder. We're going to open up the local jar. And what do we have? External editor. Oh, my proxying's not set up correctly again. This Foxy proxy, I'm having a hard time getting it to ignore Codingame, and it may be because this is hooking up to somewhere weird. Alright, so we have this. We'll use the previously selected file. We're going to upload the old one. This is just a tool that lets us use local files instead of their editor here, because editing online is really not much fun. It's just not a nice editor. It's also compacted, so we're going to be using Visual Code, and my project doesn't be there. I have a Danheim folder open. I have no idea how that happened. So Danheim, if you don't know, is it's music, different type of music. You might like it, but obviously not something you want to open in editor. But what happens if I try to open it in Visual Code? Oh, it just complains. Do you want to open it anyways? Yeah, let's open it anyways. This might be bad. This is a FLAC file, and well, it doesn't crash. That's good. I'm very impressed that it doesn't crash. This file must be massive. Alright, let's go open a folder then instead. Open folder slash. There's all my other music stuff there, you can see. I don't really have much on digital yet. It's still a space problem, so I still tend to use disks. Not that folder. So I use compact disks a lot just because, yeah, it's I don't have the space to make everything digital. Hypersonic. Now, I've totally forgotten where we were last time. We had this profiling stuff, and the docs for profiling, if you're trying to do in Rust, they have like a profile.bench, which does not actually work. It's like, it has to be profile.release, because for whatever reason, benchmarking uses that. But we're going to set up a different program today. So we have these tests wherever they create this mist-test, and this is where we use something called Criterion, which is a separate benchmarking one, which is actually fairly decent for comparing code, doing benchmarks, but it's really not good for calling a program like Valgrind, because in Valgrind you don't want to iterate something over and over and over again. You actually want to call it just once, and for that we're going to create a separate main function that calls a path just once. We're going to do the exact same test as here, but we're going to call it just once. Get my best turn, and we're going to use this to figure out where those weak points are in our code. And we have some good ideas with that already. And we're going to go over to the Hypersonic source bin, and I don't remember what main looks like, so I'm just going to copy this one, and we're going to say profile main or something. And I'm going to copy that test from over here, get my best turn. And that should be enough, because we're just going to copy it once. We're going to want to run once through. Alright, so we state that. I think that's everything. We're going to have to do a bunch of imports here. It's using state and stuff. All the stuff here. All the rest of it we don't need. Let's see if we can actually run this now. Clear and cargo. I don't remember. How do you build a special program? I don't even know how to build one program with cargo. Interesting. Must be a way to just build one. Dash bin profile main. There we go. I don't know why it's compiling all these libraries again. It should already have those. It's kind of confused as to what it needs, I think. That's okay. Uh-oh. Cannot find B. Oh yeah, that was actually the iteration. We're just going to call this once, and we're going to have to output this. And the reason we're going to output this is print line. And this is the thing with profiling you have to watch out for lots, is that you actually want to make sure this function is called. Because if I don't print this out, and, well, okay, Rust probably can't, because this is mutable, it probably can't optimize it away, but if this were not mutable, the compiler could reasonably say, you're not using the result of this, and this is an immutable function, therefore I'm just not going to call it. I mean, it's really hard to make that assumption because even though Rust has immutable state, you can still access globals, but they're unsafe, so I don't know if you can actually make that assumption or not. In any case, whenever you're doing profiling, make sure you use the results so the optimizer doesn't get rid of the stuff. Okay, so now we have target debug. It better be debug. This is the important one because that's how the... Alright, so that's running debug. So what we're going to do now is going to run valgrind on this. Valgrind -- tool equals call grind. And this could take a while, but that should be okay. Ah, that didn't take very long. It's perfect. One iteration. And now we use a tool called cache grind. This is a wonderful visualizer for this. And what do we call this thing? Call grind out dot... Oh, well, which one is the newest one? Small one. 3858. Now we looked at this last time to find the slow stuff, but we're going to do it again just so you have an idea of where we're coming from. And so this is our call graph. We have the start and we have the lang start, and so it goes through Rust internal stuff, blah 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 blah. Now we can look for the functions here. What do we want to call? Where is main? We must have our main function right here. This is our main function right here. And you can see it counts for 99% of the time, which you'd reasonably hope so, which means there's a bit of setup overhead. That's not a big deal. Get my best turn, and see how we walk down. Get by best turn, 99. Iter best turn, 96. And now we see the first split. It calls it number of times redundancy, and let's make this bigger here. So iter best turn is the place where it first splits off. And this is where we can find the first things that we want to address. Now, what's the first thing we want to address? Let's where the biggest time is. You have this apply turn, 7.9%. Great, that's okay. Now we have step state 32%, really expensive function. Likely die 23%, and get score 22%. So we were expecting that get score would be the most expensive one, and it's actually these ones here, the step state and strategies and likely die, that are the cleanest targets. And it's actually this function here, so you can actually go into this thing here and you can do relative to parent, and you can see relative to here most of the time is spent in this explode function, and also range iteration. Now this is actually wow. This here is unexpected. We're spending a lot of time in the iteration of ranges in Rust itself. 12,000 calls, so like, and this is probably the issue with debug mode. Right, debug mode is not going to optimize. I'm generally assuming that in a release mode, these two branches are just going to disappear on us. Because, wow, this is like utter shit here. And this is really a problem with debug mode on Codingame, that most of our time, and this makes it hard to optimize, that most of our time is spent iterating. And it's not even like our stuff we're doing with the iteration, it's just the iteration itself here. But we can do this find player at least. Find player at uses an amazing amount of the time, it's 67%. And we can probably cache that. So let's focus on that, find player at, and we'll just do this one step at a time to show how profiling and optimization actually works. So let's go back up to where we called step state, iter best, and you saw step state was taking about, step state is taking 35% of the time. 35%. And that find player accounted for 65% of it. So if we can actually get rid of that, and you can see it down here, if you can actually get rid of this find player thing here, then we can reduce this time a lot. And we're only looking at relative times now. And this is the problem with profiling, is that you have relative times but you don't have the absolute times. But overall, the time overall will reduce. So if we get rid of this relative to parent, the iter_best time, we should see that time reduce. So iter_best is currently at 92. If we do anything to speed it up, its relative time will go down. Ultimately, the goal will be 0, but that's unrealistic. And step state is 32% total time, and I'm going to take that to 32% of the total time. And we'll see those numbers reduce. If we can reduce that number, that's good, even if the relative scores go up. Of course, if the total program time goes down, the absolute may go down. So let's go look at find player at. So find player at is clearly one of the most inefficient things, costing us lots and lots and lots of wasted time. And where do we do that? Where is find player at? I think that's in state. Find player at. Now, why on earth do we do this? Why on earth do we call find player at? This is just really wacky. Why on earth? This is a weird function. Given a position, find the player there. What do we even call that? Well, that doesn't make sense. Find player isn't even called. Huh? Find in folder. Right there. We do it inside a loop too. This is like ridiculous. Okay, oh man. Alright, so the reason we do this is because our board doesn't actually track if there's a player somewhere. And so this is actually a little bit tough to read. So our explode function here, what it's doing is it's doing the explosions and then it's checking to see if it ever hits a player. Extremely inefficient, but yeah. Still, find player at shouldn't take that long. Alright, because we have the entities, we're going through all of the entities, and that's a real issue here. Because to find the players, we have all of these entities here. And this includes all the boxes and all the bombs. This is a pretty big list. And it's doing it inside a loop here. I'm going to close a bunch of this other stuff off. And it's doing it inside this loop. So for virtually every little place the bomb explodes, we're going to do this lookup. And so this is a huge lookup for every single bomb. And I'm trying to think of how we can optimize this. We could store where the players are on the board at all times. But there's a cost with that because currently the board, and the issue here is that the player can be on top of a bomb. And this is really annoying because when the player first places the bomb, and players can also be on top of other players. And so what that means is it's really painful. It's really painful to actually keep the track of where the players are. But iterating through the entire state is obviously not a good solution here at all. So what we can do is, how can we actually do this quickly? We can at least reduce the number of iterations. Hello, Koto Botov, welcome to the show. The first thing I think we'll do is, when a state is updated, when a player moves, we could actually track the current location of every player. So we're going to track players, and this gets a little bit difficult when reading in from the stream because Rust doesn't really like sharing pointers, so we're actually going to have duplicates of the players, and I really don't like that though. So we can separate the players off to a separate list. I think that's one of the clearest options. And that'll speed up all find player, find player. Any references to players now will go in a different list. So when we say add entity, we're not going to push players onto this list. I guess we could, but we're going to make a second players list. And I would actually prefer to have linked data structures here, but this isn't really easy to do in Rust, and it really doesn't like doing that. So that is, I'd like to have a reference to the entity and then also have it stuck in a second structure saying where the players are. But instead, let's just do it this way. Pub players is a vec of player. And this might break a lot of things because we actually loop through them. Well, now we're just going to say never loop through players. And we're going to say if ent.what player, then we're going to add them to the players instead. Self.players.pushEnt. And we're just going to return. So we're going to separate the players out in something totally different then. So now we have to look at all the places where player is used and deal with the fact that find player, and we can simplify all these players. Alright, and fine. So we can remove the players can only have that in it. And I can do it this way for cleanliness. I can stick it all in one line. And see, we already copied players, so it's not a big deal. Find player index, and find player index. Now we have to be careful where find player index is used because we shouldn't need that anymore. Because we've broken the index, so whoever calls find player index is likely doing something wrong now. And that's in the simulator. That's not so bad, because we could just say players. 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 Oops, that was bad. Players. Alright, so that should be okay. Then we go back to find player index, and that's really within the players array then. Players. We know it's only players, so now if self.players. Alright, and find player add is also going to go through the players array. And get rid of the if statement and just say if it equal to the position. Now this is fundamentally, we're not changing the complexity of the algorithm, we're just reducing it. And the reducing could help a lot. And after this we're going to look at more clear ways. But the goal in profiling is just to keep taking the low-hanging fruit until you get something worthwhile. Add entity, good, player, player, player. And right, and this is interesting. We already said get entity at position, and we already exclude the players here. So we already had this logic of excluding players, so we can actually remove this now because players will never be inside there. If find player, it's fine. And I wonder if that's good enough. We're going to clear cargo and build that again, find our errors. 88, this is in state. Yeah. I keep forgetting semicolons. I'm getting used to Leaf now where I don't have semicolons, and I've also done a lot of JavaScript and stuff where I don't use semicolons either. And cannot find player. why I can't... Oh, it's an entity, sorry. There's no such thing as a player. It's an entity. And what else do I add? That's going to screw up the rest of them, so let's just go for it. Oh, and player is going to be vec new as well. Alright, now I'm going to remove these things that we don't use. We don't use hypersonic entry just so it cleans it up. We don't use strategy for some reason. No, we don't use matrix. That just makes, yeah, strategy would make no sense. We don't use step state. Mark it unused for now, that's fine. Variable x is never assigned to. Well, x is assigned to right here. I think it's confused. This looks like it's actually confused. Why is it saying x is not assigned to? Because it's assigned to right here and right here. That's weird. That's not used. We don't need that. Good place. Well, it's apparently not used anymore, so let's go over here. Oh, it's never read. But it is right here. Is it because of this? That's kind of a shitty error message if it's because of that. Yeah, no, I really disagree with that type of warning. The reason is because the moment I get rid of this, it's going to bitch about the fact that the initial one is probably uninitialized, right? See, uninitialized. And so if you're playing defensive and initializing, then it gives you a warning with this. And so I actually disagree with this warning here, that should not be initialized, because it's forcing you, it's not allowing you to write defensive code, and I think that's really wrong. It's really wrong of it to give you a warning here. I mean, it may be unused, but the thing is here is that this is very defensive and it should be fine. Alright, let's move on. So now what we did is we tried to simplify that function, and we're gonna run it again now. We're gonna remove all the call grind stuff, and we're gonna run the val grind again. And we're gonna take a look at it now. Cache grind, call grind. I don't know why it keeps putting it over there. And now we're gonna iter best. And you can see the drop here already. So this was 92% now it's 89. It's not a huge drop, but the next step is getting quite different, right? We no longer have step state is over here, and it's dropped to 17%. This is a huge drop from 32%. So we've made a significant impact just by hitting that one for loop. We've made a huge impact in the amount of time it takes, which is really good. Now the next ones are likely die and get score. Now what bothers me a lot here are all this slicing stuff. All these range iterators, all this slicing stuff, is that there's probably only so much we can do. Is that our goal here is going to have to be kill the number of times we even get into these functions. Like likely die, I don't know, I can't reduce the number of times these are called. But I can reduce the number of times that the other things are called. So what's next on the list? Likely die. Likely die is a very costly function. So let's take a look at likely die. Where does it spend its time? Create bomb map. And create bomb map takes quite a bit, but if you see the number here, most of it's inside this matrix thing here. And same with this distance 2 in this. So matrix, whatever this is here, fill, matrix fill, oh come on! 22% to fill a matrix? Guys, we might be in trouble here. If filling is taking that long, we have a real issue here. We assumed it'd be allocation, but if it's the actual filling, then we have a real problem. Traits, extend traits. I don't know what to do in that case. Because if you look at create bomb map, well, this Reknakas, this is not that hard to set up. We made the program we wrote is very simple. We just took our test case and put it into a main function. So this is the main function here, and we just call a couple functions. We call our get best turn, and then I say we just use val grind and then k cache grind. So it's actually really simple to get these types of charts. The hard part is figuring out what we do about this fill call. So if you look at state, but I can highly recommend if you're doing profiling, the tools cache val grind is indispensable. You cannot do profiling correctly without a tool like it. I don't know of any other tool like it, to be honest. They must exist in other platforms, but it's the one I used. And I just see it works with anything that compiles to an exe as long as there's debug information. Even without any debug information works well. And k cache grind is a really nice visualizer for it. I mean, obviously there's things I'd like, but it gets the basic visualization done right. All right, so where was I again? Strategy, create bomb map. Now, our assumption was that this new is what's going to cause the time. But if you look at the thing here, and ignoring all these weird things, it's in a fill function. So this fill function is taking a huge amount of our time. But the matrix fill function, I don't think we can speed it up at all. Fill calls clear and extend. Now, Reknakas, just guessing is a terrible way to profile because you don't know for sure what it is. There's some weird things that can come up. For example, you could be spending most of your time in a fill function. But as I see clearer, if we look down, it's actually this extend function. So it is not actually fill. It's the extend function. And so this really is the reuse of the matrix, which is a problem. If we avoided this allocation, we'd have a huge improvement. And so let's just look at this right now. Likely die takes 37% of the overall time, and we're going to step one back up to edA-qa takes I had this relative before, so cross out. So that edA-qa takes No. Likely die. Likely die is 37. And edA-qa, most of the time spent in likely die? Something wrong there. Alright, so it may have something slightly wrong here, or maybe not. Most of it's in likely die. So edA-qa is 37. Whatever. And we'll go back to the benchmarks later. You can get new numbers from them. I should have written them down first of all, what our current time is. Benchmarks are good at giving time, but they're not good at profiling. So I think we're going to have to, the next logical thing here is to stop allocating these matrices. That's costing us a huge amount of time. And so we're just going to keep calling fill. And this fill here, we should probably change the way matrix is done first of all, so our fill can be simplified. How do I set up a vector with... I just do it this way. Yeah, let's do this. Let mut m equal matrix. Return m.cells.extend. That syntax is weird. Well, in any case, we're going to go with it. We're going to take this exact syntax. And we're going to map it to default. We hope there's a default that works. You can't use a matrix unless your value has a default. And that seems fine. Now what we can do inside fill now is do it slightly different. We can do a for loop here. For I in 0 dot dot self dot linear len. I hope this is only called once. It's a range, so it should be. Self dot cells I. We'll say as usize equals v. Alright, now we go back to strategy and we say get bomb map. So to create bomb map, it wants to have a reused bomb map. So who calls create bomb map? Create bomb map. Good place to bomb. And it's only used locally there, so that's really good. Likely die also calls it. So we can go straight into creating an object pool, or we can just hard code these ones. I'm trying to think whether we want to create a pool right away, or... Yeah, let's actually... No, let's do it the simple way first, because we don't need more than one bomb map at a time, I think. So this create bomb map, the bomb map doesn't survive beyond here, and the other bomb map also doesn't survive beyond. The correct way is an object pool, but let's just do it without first of all. So the strategy right at the top, we're actually going to say temp bomb map. And what does this look like again? Bomb map is a matrix of I32. And self.default, this matrix has a default. Not really though, does it? Well, what we can do in the matrix is instead of initializing it this way, we're still going to extend it. We're going to do this. We're going to do public function resize, and we're going to resize it. Self.width equals x, self.height equals y, self.cells.clear, and then we'll extend it again. And resize, we're going to say resize and fill, because we can take the value in we want to fill it with. And this becomes v. So we're going to have a resize and fill. And when we create this thing here, we can't create a default anymore. We're going to return a strategy. Good place is none. Temp bomb map is going to be a matrix. And what do they call it? Matrix new with a certain size. New, and this may seem silly, but we can simply just put any number in here, and this is just going to allocate enough memory for it. The barber shopper, that's a good point. I really don't know. The reason we used extend before, well, allocating a new vec, because the reason we used extend before is because we wanted to reuse which memory was there. Because if you do a new vector allocation, you've not actually avoided the allocation. Right? So right here, the reason the clear and extend, if this is working like normal libraries, this clear doesn't free up the memory, so this extend will reuse the memory. So we're trying to avoid the allocation and all the costs that come with that. Where I think if we create a new vector and assign it, we're actually we're gonna not avoid the allocation, which defeats the purpose of what we want to do. We really want to avoid the allocation. This resize and fill here, though, this is another one. Actually, we should probably do this a bit better. We should actually say... Yeah, let's not even call it clear. Let's just call extend. If it's too big, it's too big. Doesn't matter. And then we do self.fill v. There's probably some more optimization to be had here, but we're not going to clear. We're just going to extend. We never actually want to clear it out. We'll just add new values, and then we'll remap it. This will be interesting. So we have a temp bomb map now. Okay, we have a temp bomb map. Now it's created. That's what I wanted here. And then so when we have get bomb map, create bomb map is now going to take and mut. Alright, so we have to go back to good place to bomb first. Good place to bomb. And this should also take the mutable strategy. This has to take a strategy as well. So good place to bomb takes the immutable strategy. Strat is an and mut strategy. And create bomb map, we're actually going to give it the place to do it. We're going to do and mut strat.temp bomb map. I wonder if I can do it this way. I can let temp bomb map equal strat.temp bomb map. And just give it the bomb map here. I don't know if this is a ref. I don't know how these references always get passed. I think this is already a reference, so I don't have to do it again. And so now we're going to look at create bomb map. Let bomb grid equal and mut. We need the strategy here as well. Strat.temp bomb map. And this is where an object pool might work instead. And an object pool will be a lot cleaner here rather than hooking onto one. But an object pool is a bit more work to set up. So let's go with that strat and mut strategy. And we'll do bomb grid. And I'm pretty sure actually I have to do this again and mut. We'll figure that one out. And the bomb map now takes a grid, which is an and mut matrix I32, and no longer has no return value. So for grid, we're going to do resize and fill now. Resize and fill state.size.x, state.size.y, and we're going to fill it up with the maximum value. Okay, we don't need to return anything. And this will avoid all allocations as you matrices, assuming we got it right. Do that. And I'm sure we have errors. Let's go there. 18 self. This is actually M. That's good enough. Self.cells. Matrix doesn't implement copy, but we don't need copy. We don't even need clone on this thing. Alright. Well, how do we get the default for T now? What am I sticking in T that doesn't have a default? Aha! Is it really that syntax? Looks like it. Thanks. Thanks, Barbershop. I forgot about the fact I declared it up there. The trait standard default is not implemented. Well, I don't need a default there either. Oops, that's the wrong one. That was supposed to be strat. Likely die also needs to have the strategy. And what's strat? But that means best turn has to have the strategy as well. Strategy and what strategy? Best turn and what strat? Best turn and what's it called here? Strategy. I don't know why iCard's calling strategy in other places. Let's find out what we have. Expected 5 parameters. How many did I give it? But 4 parameters are supplied. Best turn. 1, 2, 3, 4, 5. Alright, what's this problem? 1, 2, 3, 4. Uh-oh. What used to be there that I accidentally erased? Steps. 2. There's a value of 2. I don't know why I decided to erase that. Why can't I do that? I want to do this. I want to make this a reference. How do you do an alias in Rust? This is one of the ones that pisses me off all the time. Is there any way to make an alias to this thing in this function? Or is it just one of those things I just can't do? Do I have to do this the whole time? Strat.temp bomb map. I'll do it this way, but I really don't like this. I always hit this in Rust, and I really don't like the fact that you can't create variable aliases. It's just a real pain in the ass. In that sense, maybe a object pool and a better. Yeah, but that's not going to take the reference then, Barbershop. I can try it again, but I really don't think that's going to take the reference then. Right, because if you just do this, it's just going to whine about the referencing, yeah? The strategy already is immutable. I don't know anymore. These helps are usually not clear either, because you're clearly not meant to change this, the 208, into a mutt strategy. I want a reference to it. Ah, come on. I could probably just pass its strategy. Oh yeah, wonderful. Iter best turn. Takes a good place. This is another one of those annoying things. Like good place equal strategy good place. If likely die and with strat. This now just becomes strat. See, I'm entirely unclear of why this becomes strat, but state is still and state. I'm definitely faulting Rust on this. Its rules for how it sometimes implies references and sometimes not are really poor. It's very hard to understand. And that's even if you understand pointers and shit. It just, there's like weird cases, and especially when you use iterators and stuff, I really don't like that about the language. It's just not clear why you sometimes put and sometimes you just don't. Alright, but this actually compiled, so let's see if we can run this thing. Alright, and we should have actually checked the number of refs, because that actually gives an indication of whether you're reduced it a lot now or anything. But kcache grind, let's do call grind. We're looking for a reduction in likely die, a huge reduction. And so now the call graph has changed significantly. We want get my best turn. It's still the vast majority of the time, which is not terrible because we don't know. Iter best is, yeah, we had it relative before, but likely die. So now likely die is taking more of the time than before, which is really not intended. How did the time go up? Where does likely die separate most of its time? In resize in... Now we should have been watching the time because we might have actually set the time off so much that most of the time is still spent here. But no, because we changed matrix otherwise as well, we may have actually changed the timing of matrix in other places as well, which may have screwed up the measurement here. Because the fill is no longer the dominant part of create bomb map. Create bomb map actually takes other things now as well. And the distance 2 is also matrix fill, but it still spends a lot of time in extend. Now this could be possible because we're only doing one turn, so we still have a lot of time in extend. That would reduce if you do multiple turns, but in the one turn we just have to deal with that. But it should have been lower. Like the resize and fill, extend. There's still a lot of extend stuff here. There's something weird with extend because when we did the capacity here, extend should be cheap. Resize and fill, well, let's do 30,30 because that's bigger than we know the size is going to be. It's absolutely way bigger than we need it. And actually, what's the board size? What is our actual board size? We might as well just initialize to that because that's what we'll know it'll be. And that's just the ranking there. 13 by 11, so really 20 by 20 should have been fine. Which means there's something still really funny about the cells.extend. It's like doing something it shouldn't do because cells.extend should be free because the size is already big enough. Rust vec extend. So we're going to have to avoid calling extend unless we really, really absolutely need to. Extend. Oh wait, no, I screwed that up. Extend always extends, so we should actually... So it always adds this amount. That would explain why that screws it up. How do I just set the length of the thing? I just want something that fills a whole bunch and resize. Will resize do the correct thing and not actually resize? That is, does it keep the memory? Let's just do that. Resize default. Oh, we can't use it because it's an unstable library feature. Wonderful. So just resize T default. Yeah, I don't know what the set len did. I also saw that, and that's probably okay. If I do with capacity and set len, but I think this will work just as use size. Right, because if I do with capacity and do a set len, that would probably actually work as well. But here, this resize and fill, I don't even have to... I can even avoid the resize, because if it's big enough, we already have a wrapper around it, so nothing actually needs to know that length. Ugh, I hate the binding of as. The fact that as has a tighter binding than like multiply is really kind of weird. Let's see if this helps. Let's rm cold grind all. Well, it's fewer iterations, not a hell of a lot though. Well, I guess 7 million, that could be a lot. Alright, we have start internal. Where's iter best? Iter best, I guess. Iter best turn is now taking even more of the time. So there's still something wrong with likely die, because likely die is still taking most of the time. Like our efforts here have done absolutely nothing. So the fill here is still taking up a huge amount of time. But it may be because, again, matrix is used elsewhere, the rest has gone down, but you don't see any calls to extend here anymore. You have this call to resize, that's fine. And that's in distance 2. And create bomb map is lower. And it calls resize and fill. So 8% of our total program time is given to resize and fill. Like, this is very depressing. Overall, fill gets 17.53%. So this is actually what this is saying, if you're understanding, is that of the total execution of our get best move, 18% of it was filling matrices with a blank value. And this has a lot to do with because of the fact that it's debug mode. Right? Every single one of these things to here is probably invoking a size check. Is this actually done? So let's check. Vector has some way to actually unsafely set stuff. So like the resize and fill, it takes a little bit of time, but the actual filling takes more. So let's look at the resize and fill. Vector has some unsafe functions, I think. Set. Let's look for unsafe stuff. Unsafe. Set len is one we could probably do. It's no. Let's check to see what it is first of all. Well, let's actually just call it. We might as well use set len first of all. No, because we have the resize here, not script. Let's look for other unsafe things. I don't know how to do this. Is there a way we can actually do an unsafe setting of this value here? That's what I actually want to do, is an unsafe setting. Push, place back, append, clear, len is empty, split off, resize, extend from slice, remove item, splice, drain, fill. What are these things? Len, first mut. There's a get unchecked mut. I wonder if that would do something. Is there any set unsafe mut? What do we have? We could maybe use a slice instead, so we can stop deferring to vector and go back to kind of what the barber shopper said, is that instead of storing a vec here, we could store a slice, but we don't know the length of it, so I don't know if we can do that. Can we store... Do we have arrays of unknown length? How do I do that in Rust? Can I have an array that has like no unknown length here? Then we could avoid the vec altogether. That's an option. What else can we do? And Reknakas, to come back to you about, this is the why you don't make wild guesses, because if you're making wild guesses about your program, you're never going to come across like thinking, hey, this fill function is slow, because you don't expect that. You really just don't expect to be slow. Again, it's debug mode causing half the problem, but still, even in runtime mode, the dynamic checks here are probably going to cause an issue. Alright, so I need to know how to use I'm going to drop the vec, so that's probably overhead. And how do we actually do a Rust? I just want an array of variable size. I'm just going to read the documentation. I don't use this much. It wants a compile time constant. Oh, Are those expensive to dereference boxes? Really, all I want is an unsafe vector insert. Let's see if there's a Rust unsafe vec set. I already know his runs. I checked this. Is interesting one. Game dev. Alright, so clear is bad, but we already got rid of that. So we don't actually have a clear anymore. That's fine. This push now we should get rid of because we shouldn't be using it. That's unsafe. Alright, so Barbershop, I believe you. I just want to check it out to see some references on this Rust. Unknown slice, land box. Maybe I should take box in there. Slice. Unknown length. Dynamic fixed size arrays. Alright, this guy, he speaks to my heart. This is exactly what I want to do. How do I do this stuff? A box slice, you are correct. A box slice. Let's do it that way then. Alright, so it has an actual, so we're going to hope that this is faster. We're going to use a box slice and just hope that it's faster. Box T. In cells, now how do we box this stuff up? Box new and... I've used boxes before in another app. I used them very briefly, so for strategies, we're going to figure it out here. And this should now be a vec. And we want x times y as use size. And I guess it's going to take the default. If this works, we can just do this now as well, because we just return it. We don't need to resize it. And so this resize and fill now, what we're going to do is we're going to say let len equal this. If len is greater than self.width. Oh no, we need to know the current length. Can you get the length out of this thing? It says it knows it, but how do you get the length out of it? Rust length of box slice. Well, let's check this performance comparison of a vec and a box slice first of all. We might not be able to do what we want. I don't know what he's doing. This is too complicated. Oh, I see. Can you get the length of a slice? Length of slice. I don't know, so I'm going to do this. Capacity. We'll just track it ourselves. I'm really unsure of how to do that. Well, let's try that then. If len is greater than self.cells. Do I have to unbox this? Self.cells equals box new times, this is len, and we have a value here. This is what I was hoping for. Else, I want to fill it. If we reallocate it, we don't need to fill it. In either case, we're going to set the size. Whoops. And we're going to see this start bitching to us about probably all sorts of errors. Expected use size found type parameter. That, I think. Do I have my vector backwards? Expected slice found standard vec. Oh, because vec creates a. Oh no, we have to create this into a slice somehow. Slice. Into box slice. That sounds good. Do I really have it the wrong way around? I've done it so often. Are you sure it's a comma? I think it's a semicolon, is it not? Okay, but we can get rid of this. Into boxed slice. No problem. It's not like I don't make these mistakes. Into box slice. Alright, and I screwed something up. Yeah. Well, that compiled. RM call grind. Let's see this thing actually run. Alright, so we lost about 2 million instructions, which is helpful. That means we definitely improved something. That's what this number, little number here is for. I can stop pointing at the screen. I know you can't see it. And so that gives us hope that maybe we sped it up, but it also gives us hope that we can do a bit more there and avoid the runtime checking. We're just going to be totally unsafe with this stuff and do it faster. And there we go. Likely die is now at 24.63%. We started at 37, so that's a massive reduction in time that likely die takes. And Interbreast turnaround is now to 95. That's fine. It was 98 before, so it's actually taking a bit less time. So the overhead is higher, as we want. But can we improve likely die still some more? Because the resize and fill, this fill is still taking 14% of the time, which is still ridiculous. That's still way too much. So likely die we've gotten down to 24%. And for reference, let's do fill. I'll keep track of that. That's 14%. And I mean, most of this is iteration, which is also kind of silly. We've got to find a way to do cheaper iteration than that. Does it have a C style? We could probably do a while loop instead, because this thing is creating iterators, and we could probably get rid of this and do a while loop. And again, this is really unfortunate. The fact that we're doing debug mode, it just really sucks. So if somebody from Codingame is watching again, please hurry up with the enabling release mode, because it really sucks if we have to start optimizing iterators to avoid using the language native iterators. I have no idea, but they would definitely be helpful if they could. The skeleton scripts would be easier. It does do some weird things. Because somebody might know, because I often get links from people where the code is, so that would be really cool. Alright, so I want Rust. Unsafe slice access. Let's see if we can kill this out here. Unsafe Rust. Yeah, the barbershop, that would be great. I've actually been creating here, I have this skeleton directory, right, which sets it up for my show, all the stuff we do. It creates the bundling files and everything for it, but I don't know how far you get in that, so we just have our own skeleton. I still have setup work to do when I do it, though. Can I do unsafe? Slice. Now I've not done this in Rust. I want to figure out how I can unsafely access a slice in a box. Anybody know how to do unsafe access to a slice? Azimuth pointer, what is that? That sounds promising. Unsafe mutable pointer to slice's buffer. That sounds delightful. It's strange that the X-azimuth pointer itself isn't unsafe. Alright, let's do it this way then. Fill. Let pointer equal self.cells.azimuth pointer. Looks good to me. Yeah, that's exactly, I know. Point to, this is a weird offset. I is eye size. Oh yeah, that starts to make sense. I know why it's eye size now. Alright, that's perfect. You know what, I'm actually happy to see a function called offset, because when I was thinking about doing this in Leaf, I have the exact same issues. I actually don't want to implement any pointer arithmetic because it's really such an edge case that you don't want to like overload your addition and shit just to support pointers. So people in Rust are happy to accept offset. I can consider that in Leaf as well, to just take offset as well. Now I compiled. Now I'm assuming that's faster. We're going to find out. That may not be faster, but we're going to find out here right away. That created more events than before. Oh, I probably know why. I'm willing to bet that offset in debug mode isn't an inline function. That would be sad, but that's quite possible. Alright, where are we? Got a different map here. Where's likely die? Likely die is still at 24%. And fill is still at 14%. So we've not sped it up at all there. And it's still the stupid iterator thing. So how can we get rid of this iterator to make it faster? Let's just not use an iterator. Well, I is less than max. I plus equals 1. I'm curious as to whether this actually makes a difference or not. Alright, what happens? Was that a significant drop in the number of events collected, or was that a significant gain? I don't remember the first number. I've been so focused on the second number. Well, let's look at the thing here. What happened here? Alright, so it's a massive drop. Thanks for everyone else. That's a massive drop, which is really unfortunate. And what happens now to likely die? Likely die is now dropped to 13.88%. That's half the time it was before, or almost half. 13.8%. And you notice it doesn't even have anything deeper inside of it. Like in the main map here, it doesn't even show up. The points of interest aren't even there. But let's take a look anyways. Right, it has no more low-hanging fruit. So that's been a massive performance improvement. And this is the one I want to reiterate. Anybody, please, go bitch to Codingame about the lack of release mode, because although Rust may not be perfect in this sense, this loop should not be necessary. What we had before, yeah, I mean, this is definitely it. What we had before, I'm reasonably certain, even in Rust, even if it's not the most efficient, should have basically compiled to this. Because it's not that hard for the optimizer to see this stuff. And this is, like I say, this is one hell of a speed improvement. And what this basically means now is that we're going to have to do this same crap for all of our iterators. And I'm not sure how excited I am about doing this, because this basically takes nice clean code and makes it look like shit, yeah, just for the purpose of speeding it up, just because we can't compile in release mode. And algorithmically, we might be able to get away with reducing the number of times, but this is just, that is crazy, and I don't know how else to do this then. I mean, this is really bad. I'm going to copy this, and I want to see what we had before, first of all. I'm going to comment this out. This should compile to be just as fast as the next bit in release mode. I hope. Because there's nothing, I mean, these are fairly basic optimizations for a compiler to pick out. Like linear len, it's going to look at and say, oh well, it's static, doesn't need to update that. The iterators going to all be inlined and stuff like this, and maybe not this step, maybe not this step. Maybe there's a mutable iterator to be better, but this here is a massive difference, and we're just going to deal with that. Okay, so now, knowing that, what's our next target here? What do we have? K-cache grind. What was our next target of attack? It's going to be very basic minimum shit, I think. What spends the most time in a whole function? Slice. Iterators. Ah, not a surprise. Most of the time in the program is spent inside an iterator. Where from, though? Boxes within bomb range. Alright, so let's go there. Boxes within bomb range. Boxes within bomb range. I'm just writing these down on my paper so I have a reference. Is at an amazing 26.67%. Alright, and this is split into 3 bits. Is entity within bomb range? And this is an iterator. So 5% of the time is within an iterator for is entity within bomb range. So let's go check out is entity within bomb range first. Is entity within bomb range. And that's 12.02%. Alright, this is a significantly major low-hanging fruit when you're talking about when you have something that takes 5% of total execution time. That's not not delightful. And you see some other obvious stuff here, but all these 2.4s, you basically ignore them. As long as you have these 5%, you keep going down. The goal of performance testing is to make these branch outs here as flat as possible for profiling so that they're all, so there's no big ones. Like when everything's down to a low percentage, get rid of all those first, and then you can look at algorithmic things as well. But right now we're suffering from very basic things, is entity within bomb range. Because we don't actually believe we have algorithmic improvements. That's a very important thing to think, that we think the approach we're taking is fine, and in release mode it works very well. Release mode we get quite deep, and there are some algorithm programs to make, but we still rely on doing this stuff really, really fast. Alright, so strategy. Is entity within bomb range? And we have two things here, and again, this is getting really... This is getting really stupid here, to do stuff like this. Let mort-ora-y equal 1, while I is less than bomb.param 2. I plus equals 1. Now I'm going to make only this change, and let's see how much of a difference that makes. Because again, if this makes a huge difference, my motivation to get further in Hypersonic, whatever this is, has dropped significantly, because it's no longer a matter of, well, let's just test it first. Before I start saying that, let's just actually test that first. But it would make a huge difference as to whether I actually want to keep optimizing this. Yeah, that's another significant drop. We went from 49 million events to 46 million events. That's a 5% drop. If not more. Alright, so boxes within bomb range drop down to 22%. That's good. So that was from 26 to 22. And is entity within bomb range went down to half the time. And you notice this get def is taking a lot of time too. We could probably speed that up as well. Alright, so what I'm going to have to check here is, I'm actually curious now. Well, I'd like to know what the difference is in release mode. Alright, Barbershop, go grab your snack. Let's do this matrix first, because we have the get def. Get def we know we can make faster now. Get def is valid. And this should have been totally fine, but for optimization, optimized. We're not going to call is valid. We're totally going to duplicate this because we know it's not inlining it. Which can return this stuff. Else def. We're just manually inlining, which you should never ever have to do in a realistic scenario. And now we're going to do something totally awful. This get here. We could almost optimize get, but let's not yet. we're going to do this. We're going to do point to cells.azimuth pointer.offset. Location.y times self.width plus location.x as I size now. Alright, so that should speed that up as well. It is like it was at 6%, 22%. Oops. Oh, unsafe is fine. Unsafe, go for it.
No.
Cannot borrow is mutable. Oh, we don't need as mutable. We just need as pointer. There we go. And let's run this again. That wasn't a huge drop in events, so it may not make a big difference, but we're looking for is entity within bounds, see if it made a difference. No, it did not. So we didn't gain much there. We didn't really gain a significant amount by that change. Which is weird. But I mean, maybe it makes sense. Maybe singular calls aren't that bad. So that didn't help much. So I always undo the things that don't help much. Let's look for something else. Let's run this all again. And let's see. Well, it did remove. Right, it was yeah, no, it doesn't make a big difference. So let's look what's next in the list. What takes up the most amount of time? It's still a slice iterator somewhere. Still a slice iterator messing with us. And still within boxes within bomb range. There's 2 of them. Right, if you start looking back, you start looking at these filtering things. This is where I'm kind of losing motivation to go for this, because basically we're going to hand unroll all of these iterators, which is no fun, but you can clearly see them here, that these things called 7,000, 4,000 times. This is accounting for so much time that the iterator has this massive overhead. And so right now, so our iterators, let's just check this. So our iterator right now, and this is the top function here. We'll just say the iterator functions. We'll guess which ones they are, taking like 5.21% of the time, and that's really ugly. And these all add up, right? Because these are self. Self times me just in this function. So there's another iterator taking 4.16, and this one here, partial equality. This is a partial equality, a check for equals on an entity type. This is really bad. Is also taking 4%. So this is a huge chunk of time just wasted in these functions. And even this box function, the box taking 3%. Like, this is all really like crap that shouldn't be there. Let me just take a new screenshot here. So we have this here, so we have a good reference for it. And I'm really guessing that this core pointer null is not I don't know what this is, but to be honest, something called null is probably not supposed to take 2% of the time. And something called 160,000 times is probably just supposed to be inlined. And there's probably nothing deserving this being called so much, so we're lacking a lot of inlining. So let's build this again with release mode. and then we'll tool grind that one. Whoa, why does it say unoptimized plus debug info? That's not correct. I don't like this tool. How do you get rid of this? I don't like Visual Code. They don't give you menu items to get rid of sidebars. I want to get back to the file browser. There you go. Alright, so we're gonna go back to the TOML file. I think that's the get rid of this stuff. We'll comment it out for now. Whoops. Or not comment it out. Or whatever that is. That symbol. Come on, compile. Now, somebody made the comment before that Rust is really slow in debug mode, maybe worse than other languages, but it's really not something you can say against the language. I mean, debug mode is just the way it is. Barbershop, we've used the built-in profilers. I mean, the benchmarks. For benchmarks, I use a lot of tools, but for actual profiling, I've never used tools other than Valgrind, not recently at least. For actual profiling, I find Valgrind is wonderful because it does a really nice calculation. Unless you're using a lot of hardware stuff, then it's weird, but for actual pure calculations, Valgrind is wonderful. Alright, so now I have an optimized build. So let's run Valgrind on that one. Whatever we have, let's get rid of them first. And we're going to do release. Wow. Just wow. You guys see that number, right? This was a number that was 49 million before. So just running in release mode basically got rid of most of the program. Let's just take a closer look at where it is. In the self scores, yeah, it's none of the iteration stuff is up there at all. I mean, we have, there's like no hanging fruit left here. This is really scary, right? This is like, there's nothing here to optimize. And so iter best move is the slowest, and that's what we'd expect. And you already see it starts to become a real issue to optimize this, but we don't have to. This completely demotivates me from trying to optimize this, though, and this is actually a defect that Codingame has to fix then, because there's no way I can optimize to the point that this release is going to do. And I know the other people are running in debug mode as well, but they have different, their compilers are different, and Rust is just simply, nothing's meant to run in debug mode. And this drop here, there's no way I'm ever going to tune it to get down to that level. It's just not possible, and we're making our code look like crap. And knowing that this is just within reach just kind of defeats the whole purpose of trying to profile and optimize, because we'll just never do a good job as what the release mode can do. And in release mode here, we still see create bomb map is still coming up. So there's still stuff here we could actually optimize. And the one here is this extend. There's a vector extend, and more than likely, we should just cache a vector. This is creating a new vector, and more than likely, if we cache a vector, we'd actually get rid of most of this time here as well. But the create bomb map here, you see, it's even hard to see, which would drop the node cast so we can see the other ones that take up more time. There's no low-hanging fruit here anymore. The barber shopper, somebody mentioned there is a way to do that. You don't submit with Rust then. There is some way to submit a binary. It wasn't necessarily legit, but there is a way to do it, and it's certainly not allowed in the contest, and I don't really want to go down that route. Because it's just, I mean, that's getting more of a thing. But so this is actually pointing towards the fact that we're actually done with Hypersonic. We can't play Bomberman quicker because with that huge gain there, and the key to what we're doing here is all we're trying to do with this optimization is, and we do iter best turn, is this number here, this 2. We're trying to get this up to a 5. This is the depth of moves we search through. And each one doubles a time, and that drop in time there, if you got down to 2 from like 50, actually we were at 60, so 2 down to 60, we got an improvement there. That becomes 2, 4, 8, 16, 32, 60. That would easily get us to like 6 or 7. And that's all we really know. We know from other people saying that that would get us into the Legendary League without a problem. But we have no way of doing that. We're stuck at 2. Just stuck at 2. And our changes might be enough to get us to 3. We might be able to get to 3 now, but that's not going to get us much further. And so there's really not much more I can do here. I mean, I really don't want to go down the route of hand rolling all these things. So we're just going to have to... Well, Barber Shopper, they have... I'm just going to leave this for now. They have the compete mode, but they also have contests, and it's been definitely said that it's not allowed in contest mode. You can't do that in contest mode. Somebody said that. Whereas in the actual games mode, apparently you can upload binaries, and it's not... I don't remember if it was just frowned upon or disallowed. I don't remember for sure. But this is really unfortunate. I'm going to post another message and reference this show saying, look, they have to enable release mode. And I absolutely know that it's going to skew the ladders, and it's going to make it harder for us to get into Legendary. But the thing is, I would rather compete on the logic of my code rather than doing manual optimizations that a compiler can do. So be it. Everybody gets pushed up the ladder that's using a searching strategy. I'm fine with that. I'm actually, it's much nicer than having to do any of this hand rolling crap. And so I'm just going to send another message, and I'm going to quote some of these numbers here. And like the key one was basically that we started at 60, and it gets us down to like literally 3 or something. That's most of our time just wasted. So I think that's it for me today. Like, there's not much I can do. I think we're done with Hypersonic. We're going to have to look for another one, because I'm not going to unroll all that shit manually, knowing that it's so easy to do a different way. Which one could we play next? Let's look at some of the other ones. Program. Think of what one we could do next instead. And we might actually have to stick with one of the heuristics, but I don't like the heuristic ones. I like the searching ones, and we're going to have to find something that's fun to start. We could actually go do Borders of the Galaxy, because we already know we have a Legendary League bot for that, and that would just give us some cheap points. We might do that. We might just look at that. Otherwise, we'll look at one of the random ones. Code for Life, we're at Silver, and I took the searching approach for this one as well. I actually coded this up and did a search approach, and we actually did horribly with it. Okay, we're Silver, and to me Silver League is that we failed. I mean, if we're not in Gold League, I consider it a failure. This is not to dissuade other people. Silver League is not easy to get into. It's just at what I have for my expectations. I'm assuming Gold League at least, and then hoping for Legend League in most of them. But we had a searching strategy here as well, and it wasn't a problem with performance in search of how far we could search. Okay, it was. Again, no, it kind of was. Because our search depth was so limited, our scoring was shit, and we actually had to start building in heuristics, and so we ended up doing something horrible. We had the search depth thing with lots and lots of heuristics, and they just didn't mesh well together. So our little bot frequently just stands around doing nothing, or throwing things back and forth. On pure heuristics, this would probably be more fun, and if I went back to this, I would just rewrite this using hard-coded logic the whole way through, and we'd probably do much better. And I think that's all these guys here up here that were on our show at one point actually said they just did that approach. They didn't do searching, they just did like hard-coded rules and stuff. But I don't feel like approaching doing that game again. It was a cute enough game to play, and there's a lot of room for doing that type of heuristics. And it's a very fixed state game, which makes it interesting. So it's very different than like the, say, Borders of the Galaxy, which is an open world game. So was the last competition. I didn't like that much. I'm kind of tired of the open world games because they're essentially the same thing. It's like just, the fixed state is much more fun to play with. And this Wonder Woman, if we see flood fill and minimax and simulation, this is pointed towards optimization is going to be an issue. And Fantastic Bits, I don't know what that is. Which one does it have? I'm only going to play ones with graphics now. Does it have graphics? It has graphics. Let's see what this one does. Okay, and this is another open world game, so I don't want to do any of these right now. I've done enough of them for a while. I want to choose something that's not an open world game. And what else do we have? Platinum Rift. Platinum Rift 2. What is this one? What does this look like? Well, this is not open world, so to say, but it's very close to it. That's a lot of agents to maintain. I'm assuming you control all of them. That might be an interesting one to do. Maybe we could check Platinum Rift next time, or Platinum Rift 2. We'll start with 2, because 2 is always better than 1, isn't it? And, oh, Poker Chip, what's that one? Poker Chip Race. Sounds a bit weird. Not many people have... Well, there's a lot of people played it. Oh, no, that's an open world. Oh, no, God, no, not that. That's another open world one. We're going to have to get used to doing the open world ones. Or we just go back and do it in practice. But we like the competition because we like our points, yeah. And we're just going to fill enough of them that when we have this master thing... You see how we drop because we don't play the Clash of Code often enough. We can get back up there. But the contest, if we do enough of them, we just want to get to Grandmaster level. And I think that's where we have to break 1,000. And if we just do enough competitions to do that, we don't have to do so well in them, we just do enough of them. But I think that's enough for me to now. I'm going to write another forum post on this point, at some point, saying, look, they have to get release working, because otherwise we're just wasting effort. We're not giving anybody a good message about Rust. I mean, you shouldn't have to manual and rule stuff. This loop we did here in this fill, this shouldn't be so costly, and I think that's it for now. Thank you for watching, and probably not here tomorrow, but Thursday I should be back in the evening, either doing another coding game or Leaf, and I might do Leaf during the day. We have that game coding, and that's also fun. We do the game coding. If you like game coding, like graphics coding, come join me for that type of stuff. Well, it'll always be something fun. But we'll keep doing Rust as well, learning its intricacies and seeing how this works, and we'll just keep doing games. So I thank you very much for watching, and we'll see you again later in the week.